I want you to visualize a specific kind of pressure. You are in London, Canary Wharf, or maybe Manhattan, near Hudson Yards.
Okay.
It's the 45th floor. The room is all glass. The view is, spectacular, but the air conditioning is just a little too loud.
Right, that specific sterile corporate silence, the kind that just amplifies your own heartbeat.
Exactly. And sitting across from you is an engineering manager who hasn't smiled in about 45 minutes. He's wearing a Patagonia vest, looking at a printed copy of your resume like it's a piece of evidence.
Because in a way it is. He's looking for the lie. He's
Yeah.
looking for the gap between what you claim you can do and what you actually know.
The coffee in the paper cup between you is stone cold.
Mm.
And he slides a whiteboard marker across the table. It makes that distinct scraping sound against the mahogany. And he says, I don't care about your hobbies. I don't care about your blog. Draw me a system that handles $1 billion a day and doesn't crash when AWS has a bad morning.
Wow. High stakes.
The highest. Today on The Deep Dive, we aren't just talking about technology. We are role-playing the gauntlet. We are simulating the architecture interview.
And this isn't some hypothetical. The sources for today include, real technical interview questions from Tier 1 banks, architectural diagrams from high-frequency trading platforms, and the actual resume of a candidate we're going to call Sachin.
Sachin is our protagonist today. He's applying for a senior back-end role at a massive, too-big-to-fail financial institution. We have to keep the client anonymous, so let's just call him the bank.
Right.
But there's a twist.
There is always a twist. If it were easy, they wouldn't be paying a senior salary.
This bank, this dinosaur of legacy finance, wants to build a bridge. They have a functional loans application in the U.S. Office, standard stuff, Java, SQL. But a new business lead wants to integrate smart contracts from the ground up. They want a control plane for transparency and auditability.
Which is a massive cultural and technical collision.
Yeah.
You're taking a traditional finance workflow TradFi and trying to inject decentralized finance TechDeFi right into the arteries of the bank.
Right. And to do that, you need a very specific kind of engineer, someone who speaks fluent legacy bank, but also speaks a crypto startup. So the mission today is pretty simple. We are going to grill Sachin.
And I'll be the engineering manager.
I'm going to play the role of the candidate. I'll advocate for his architecture.
And I'm going to be skeptical. I care about risk, I care about compliance, and I want to see if you actually understand the primitives or if you're just, stitching together libraries you found on GitHub.
I'm ready to sweat. Let's look at the dossier. Who is Sachin Chitre?
So I've spent some time with his profile. It is, it's distinct. It's a study in dualities.
It really is. On one hand, you have Sachin the Enterprise Pro.
Right. 2019 to 2024 at Direct Line Group. That is insurance. Highly regulated, heavy volume. He was doing fraud detection using Java and Spring Boot. This checks the safe pair of hands box.
He knows what a change approval board is.
Oh, yeah. He knows you can't just deploy code on a Friday afternoon.
But then you flip the page to his current role, April 2025 to present, ChainCron.
And this is where the eyebrows go up. ChainCron is a decentralized automation marketplace. He's building AI agents, writing Solidity smart contracts, dealing with public blockchains. It's the Wild West of Web3.
So the narrative arc of this whole interview is pretty clear. The bank needs to know, is this guy a solid enterprise architect who picked up some cool new tricks?
Or is he a crypto cowboy who's going to come in here and just break our compliance engines?
That's the question.
And frankly, as a hiring manager, I'm worried about flight risk. Founders are hard to manage. But before we get them in the room, let's look at the rec, the job requisition. This is document 99541. What are we actually hiring for?
Well, on the surface, it looks like a standard enterprise laundry list. Senior back-end developer. Responsibilities. Collaborate with cross-functional teams, design microservices using Java Spring Boot, create RESTful APIs, gRPC.
It screams standard Java shop.
Totally. It asks for strong expertise in core Java, J2E, CI/CD, Agile. If you just read the top half, you'd think we were hiring for, a maintenance role on a legacy system.
But you have to read the fine print. You always have to read the fine print. Look at the talent profile section at the bottom.
Oh, I see it. Buried right there under the preferred qualifications. Experience with Ethereum, Hyperledger Besu, and EVM-based platforms.
That is the smoking gun. You don't put Hyperledger Besu on a job description for a standard loans app unless you are building a private blockchain network.
Right. To those listening who might not know, Hyperledger Besu is an Ethereum client, but it's really designed for corporate use. It allows for things like permissioning, so you can control who can connect to the network.
Exactly. This signals the strategic pivot. They are building a control plane. They want the transparency of a blockchain for audit trails, so regulators can see exactly what happened and when, but they want the control of a bank.
So they aren't going to run this on the public internet.
Not a chance. This explains why Sachin got the interview. He's a bridge. He lists Hyperledger and Solidity right next to Spring Boot and Oracle DB. He's a purple squirrel.
Okay, let's bring Sachin in.
Okay, let's do it. You've got his resume. He sits down. He's probably a bit nervous. How do I start?
Do you ask him about the crypto stuff immediately?
Absolutely not. That's the shiny object. I need to know if he can build the foundation first. If he can't handle high-volume Java microservices, I don't care how good his smart contracts are, the bank runs on Java.
Good point.
So I'm going to start with the basics. Sachin, draw me the architecture of the most robust, high-scale system you have ever built.
Okay, I'm standing up. I'm walking to the whiteboard. I can feel your eyes on my back. I'm grabbing the marker. I'm drawing the fraud detection system from my time at Direct Line Group.
Walk me through it. What am I looking at?
Okay, so in the center of the board, I'm drawing a big box. Yeah. That's the scoring engine. This is the heart of the beast. Surrounding it, I'm drawing satellite services. To the left, we have ingestion. This is where the claims come in. We were talking high volume, REST APIs, claims data hitting us from aggregators, mobile apps, you name it.
Okay. What's the stack handling that ingestion?
We are using Java 17 and Spring Boot. We moved away from the older monolithic structures. These are all microservices. And crucially, they are running on Kubernetes K8s. I'm drawing the K8s cluster box around these services now.
Okay, why K8s? Why not just run it on bare metal or, simple EC2 instances?
Because of the burst traffic. Insurance claims aren't flat. You have spikes, storms, big events, sudden influxes. So I'm drawing the HPA, the horizontal pod autoscaler. When the CPU usage spikes on those ingestion pods, Kubernetes just spins up more replicas automatically. We don't have to wake up at 3 a.m. to provision servers.
Good. Now, storage. Where is all this data going?
Speed is the name of the game here. We can't have a fraud check holding up the user experience for 10, 15 seconds. So for the immediate read-write, I'm drawing a cylinder for DynamoDB. No SQL, it's fast, key value lookups. We dump the claim payload there for immediate processing.
Okay, I see the happy path, but I want to pause on that diagram. You've drawn a line connecting your loan processor to this scoring engine. You mentioned it uses an AI model.
Yes, a TensorFlow model.
In the real world, that line is a network call, and network calls lie.
They time out, they hang.
Yeah.
Packet loss, it happens all the time.
Exactly. So simulate a bad day for me. It's Black Friday, or maybe a massive storm just hit. Everyone is filing a claim at once. Your AI model gets overwhelmed and starts taking 30 seconds to respond. What happens to the threads in your Java application while they're waiting for that response?
Well, if I just did a standard HTTP call, those threads are blocked. They're just sitting there consuming memory, waiting for an answer that isn't coming.
And eventually,
the thread pool is completely exhausted. The entire ingestion service stops accepting new requests because it's too busy waiting on the old ones. It's a cascading failure.
Correct. You've just described thread starvation. It's how a single non-critical feature can kill the entire bank. So, look at your resume. You listed resilience patterns. Prove it. How do you stop the bleeding?
I would implement a circuit breaker.
Don't just give me the buzzword. Explain the mechanics. How does it physically work in the code?
Okay, so think of it like a fuse in your house. I wrap that network call in a state machine. Normally the state is closed, electricity flows, traffic goes to the AI service, but if we see, say, 5 timeouts in a row, or if the error rate crosses a certain threshold, maybe 50% click.
The breaker trips to open.
Exactly. And this is the crucial part. Once it's open, the Java app stops trying. It doesn't even attempt to send the request to the AI. It fails immediately inside the application.
Which saves your thread pool.
Right. The user gets a service busy message instantly. Or maybe we default to a pending manual review status, rather than just a spinning wheel for 30 seconds that ultimately times out.
But here is the nuance that most juniors miss. How do you ever recover? Do you have to restart the server to reset the breaker?
No, that would be a nightmare. The circuit breaker has a half-open state. After, say, 60 seconds of being open, it lets one request through. Just one. A test balloon.
A canary?
A canary, yeah.
Yeah.
If that one succeeds, it resets the whole thing to closed. If it fails, it goes back to open for another minute. It self-heals.
Okay. That is the answer I was looking for. Fail fast, recover automatically. A lot of people put resilience on their CV, but they can't explain the half-open state.
I've learned that lesson the hard way. I've seen production go down because of a third-party API hang.
We all have. Now let's touch on migration quickly. You were at Halfords before Direct Line. You moved them from IBM WebSphere to JBoss and Spring Boot. That's a classic strangle the monolith scenario.
Oh, absolutely. WebSphere is, well, it's heavy. We had to break it apart piece by piece.
How did you handle the interface changes? Your resume says you went from SOA to REST, right?
We did. And you can't just flip a switch on a system like that. We had to run them in parallel. We built the new REST endpoints in Spring Boot, but we kept the old SAP interfaces active for the legacy consumers that hadn't migrated yet.
The strangler fig pattern.
Exactly. We built a facade. Over time, as we migrated the clients one by one, we could turn off the SOP endpoints. It's like changing the tires in a moving car. You don't stop the car.
Okay. I'm satisfied with Sachin, the enterprise developer. You know Java, you know resilience, you know how not to crash a bank, but that's not why we are having this specific interview.
You want to talk about the weird stuff?
I want to talk about ChainCron. I'm looking at your resume, and it says you built a decentralized automation marketplace. You're using AI agents, Solidity, Ethereum. This is a totally different paradigm.
It is. It's a different world.
So, wipe the whiteboard, clean slate, draw me ChainCron. How does it actually work under the hood?
Okay, erasing the fraud engine. Now I'm drawing a 3-layer cake.
Layer 1.
Top layer, the user experience. This isn't a terminal window. It's a nice, clean Next.js front end. But here's the kicker. It has AI embedded. We use LangChain. The user types in a prompt, something like, every Friday, check the yield on AAV, and if it's above 4%, move my USDC there.
So natural language to code.
Exactly. The AI builder parses that intent and constructs a workflow, a series of steps.
Okay, layer 2, the middle of the cake.
Middle layer. Yeah. Orchestration. This is all off-chain. It's a Node.js backend running on Google Cloud Platform. It stores the workflow definitions in Firebase. It's the traffic controller for the whole system.
And layer 3, the foundation.
Bottom layer. On-chain. This is where the rubber meets the road. These are Solidity smart contracts deployed on Ethereum and Polygon. When the workflow actually executes, it has to move funds on the blockchain.
Okay, stop there. This is where I have a conceptual problem. You have a Node.js server, which is Web 2, centralized, triggering a smart contract, which is Web 3, decentralized. How does the contract know it's time to execute? Smart contracts are passive. They don't have a cron job. They don't wake up on their own.
You nailed the core problem. That's the Oracle problem and the automation problem combined. The blockchain is a walled garden. It can't see the time, and it can't see the outside world.
So how did you solve it? Your resume says Chainlink oracles.
Right. We used what's now called Chainlink automation. It used to be called keepers. Basically, we register an upkeep contract. Chainlink has this huge decentralized network of nodes that are constantly pinging our contract every block and asking, do work needed? That's a specific function, the check upkeep function.
So the Chainlink nodes are the heartbeat. They are the external trigger.
Exactly. If our contract returns true, based on whatever logic we define, like is it Friday, Chainlink submits a transaction to execute the main function, the perform upkeep. That's how we bridge the gap. We don't rely on our single centralized server to wake up the contract. We rely on a decentralized network of node operators to poke it.
Okay, that covers automation. Now explain the AI to transaction bridge. Your AI makes a plan, but an AI is just text. It can't sign a transaction. It doesn't have a private key.
Correct. And we never, ever, ever give the AI a private key. That would be a security nightmare.
A hallucinating AI just draining your wallet. I thought you wanted to donate everything to a random meme coin.
Exactly. I maximize your joy by donating all your funds. No thanks. So the architecture separates intent from execution. The AI builds the payload, the hexadecimal data structure that says, call function X with parameters Y. It presents this to the user in the Next.js frontend in a human-readable format.
And then?
The human then has to sign that intent with their Web3 wallet, something like MetaMask. The AI drafts the contract. The human notarizes it.
Okay, that's a critical distinction. You have a human in the loop for the final authorization step.
Always. It has to be that way.
Let's talk about identity. This is huge for the bank. In the bank, we use Active Directory, OAuth, SAMML, JWTs. In ChainCon, you're using what? Anonymous Ethereum addresses?
Both. And this is where it gets really interesting for the GLT project here. We had to map Web 2 identity to Web 3 identity. We allowed users to log in with Google using OAuth 2.
Okay, but Google doesn't know what an Ethereum wallet is. There's no link there.
No. So we used a mapping service. This is part of the Wallet Connect and RainbowKit stack. When a user logs in with Google, we can generate a non-custodial wallet for them in the background. Or we can link their existing wallet signature to their user profile in Firebase.
So you're essentially maintaining a link table. Google ID 123 maps to wallet address ABC.
Pretty much. We verify the wallet ownership by asking the user to sign a message. A nonce. Something simple. Sign this message to prove you own this address. If the signature matches the address, we link it to the Google account. This allows us to have RBAC role-based access control in the app while still having on-chain verifiability.
Okay, Sachin. You've convinced me you understand the mechanics of Web3. You aren't just copying tutorials. You've dealt with oracles, signing, and identity mapping.
I'm ready for the boss battle.
Good, because now we are going to do the simulation, the GLT module.
Lay it on me.
Here is the marker. Here is the scenario. The U.S. office has the Loans app running. It's Java. It uses a standard SQL database, let's say Postgres. It works. But the auditors are unhappy. They say the data in the SQL database can be manipulated by a database administrator. They want a golden record that is immutable.
They want a blockchain audit trail.
Exactly. We want to implement a control plane. Every time a loan moves from approved to disbursed to repaid, that state change must be recorded on a Hyperledger BSU private blockchain.
Okay, I'm with you.
The constraint. You must use our existing Java stack. I don't want you rewriting the Loans app in Node.js, and the US team is skeptical of this new tech, so you cannot break their existing application. Design the integration.
Okay, I'm drawing the existing Loans microservice on the left side of the whiteboard. It's Spring Boot.
Yeah.
It talks to a PostgreSQL database. That's the system of record for the application itself.
Correct. That's what exists today.
Man, we need to get data from there to the Hyperledger BSU node on the right side of the board.
How do you connect them? Do you make a synchronous HTTP call from the loan service directly to the blockchain node?
I could, but I absolutely wouldn't. That would be a huge mistake.
Why? Tell me why.
Two big reasons: latency and coupling. Even a private blockchain is slower than a SQL write. It involves consensus, block times, all of that. If I make the user wait for the blockchain confirmation, the Loans app will feel sluggish, unresponsive.
Okay, that's latency. What about coupling?
If the blockchain node is down for maintenance or just has a glitch, I don't want the entire Loans app to fail. The business needs to keep approving loans, even if the audit trail is momentarily offline. They are two separate concerns.
Good answer. So what do you use instead?
I see Apache Kafka in the job requirements. I'm going to use that as the spinal cord here, the messaging bus that decouples these two systems.
Walk me through the data flow. A loan officer clicks approve. What happens next?
Okay, so the loan officer clicks approve. Two things need to happen. One, we update the Postgres database. Two, we write the event to the blockchain.
If you try to do both of those in one synchronous transaction, you are going to have a bad time. What if the database write succeeds, but the Kafka publish fails?
Exactly. Then you have a ghost record. The loan is approved in SQL, but the audit trail never got the message. The data is now inconsistent, corrupted.
So how do you solve that?
I'd use the transactional outbox pattern.
Define that for me.
Instead of writing to the database A&D, sending a message to Kafka in two separate steps, I just do one thing. I write to the database. But I write two things to the database in the same single atomic transaction. I write the loan approval state change, and I write a message record to a separate table called the outbox.
Why go through that extra step?
Atomicity. SQL transactions are atomic. If the database save works, the outbox message is guaranteed to be there. They commit together or they roll back together. There's no in-between state.
Okay, so now the event is sitting safely in a SQL table. How does it get to Kafka?
I'd use a connector tool like Debezium, or even a simple custom polling service. It watches the outbox table, and as soon as it sees new records, it publishes them to a Kafka topic. Let's call it loan events. Then it marks them as sent.
Okay, that's robust. Now, you have this event in Kafka, loan approved. Who reads it?
I'm introducing a new microservice. I'll draw it on the board. Let's call it the Blockchain Connector Service. This is also a Spring Boot application. Its only job is to listen to the loan events topic.
And this service talks to the blockchain.
Yes, this service holds the private key, the back authority key, in a secure vault, like HashiCorp Vault.
And how does Java talk to the EVM? Hyperledger BSU speaks Ethereum JSON RPC. Java doesn't speak that natively.
I'll use Web3J. It's the standard Java library for Ethereum. It's like JDBC, but for blockchains. It wraps all the complex JSON RPC calls into nice, clean Java objects. So my connector service takes the Kafka event, creates a transaction payload, something like record loan state, loan ID, new status, data hash, signs it with Web3J, and broadcasts it to the BSU node.
This brings us to the biggest headache in distributed systems, Eventual consistency.
A gap.
The gap. The loan officer sees approved on their screen because the SQL DB is updated instantly, but the blockchain hasn't written the block yet. For 3 seconds, or maybe 10 seconds, the system of record and the audit trail disagree. As a bank auditor, does that scare me?
It shouldn't, provided the gap always closes.
Yeah.
But we need monitoring. We need alerts. If that gap persists for more than, say, a minute, we have a problem. We need an alert to fire.
What if the transaction fails? What if the blockchain rejects it because of a smart contract logic error, like a require statement fails?
That's the risk of async. If the blockchain rejects it, the connector service needs to handle that failure gracefully. It should publish a LUN audit failed event to a dead letter queue.
And then it's just stuck there.
No, then we need a reconciliation process, an operational dashboard. A support engineer sees the alert, investigates why the blockchain rejected it, maybe the loan ID was malformed, and perhaps fixes the data and replays the event. The key is, the business, the loan, move forward, but the audit is pending. For a control plane, this is usually an acceptable trade-off.
I agree. If this were a payment settlement system where we were moving actual money, we might need stricter blocking, two-phase commits, things like that. But for an audit log, async is safer for availability.
Exactly. We prioritize the availability of the core loans app over the immediate consistency of the audit log.
Let's dig into the blockchain side a bit more. You mentioned Hyperledger Besu. Why are we using that instead of just deploying to, say, Ethereum mainnet, aside from the obvious privacy concerns?
Finality. This is the single biggest technical reason for banks and enterprises.
Explain finality to the team.
On a public blockchain like Ethereum mainnet or Bitcoin, finality is probabilistic. You technically never know with 100% certainty if a block is permanent. It could be reorged. The chain could switch to a different, longer fork, and your transaction could vanish. That's why crypto exchanges ask you to wait for 12 confirmations.
And a bank cannot operate on probably. We need to know, is the record written yes or no?
Exactly. Hyperledger Besu uses a different consensus mechanism called IBFT 2.0 Istanbul Byzantine Fault Tolerance. It provides instant finality.
I know.
Meaning, as soon as a block is minted and added to the chain by the validators, it is impossible to revert it. It is done. It's final. This makes the Java listener logic so much simpler. We don't have to handle chain reorganizations. We just listen for the block, and we know it's the absolute truth.
Excellent. That shows you understand the underlying protocol, not just the API. Now, one last technical trap. Smart contracts are immutable. You deploy it, and that code is set in stone.
Right.
What happens if you find a bug in that loan audit smart contract 6 months from now? You can't change the code.
Oh, the immutability trap. It's a classic.
Exactly. If you deployed a bug, do we have to migrate all of our historical audit data to a new contract? What a nightmare that would be.
Not if we design it right from day one. I would use the proxy pattern.
Sketch that out for me.
Okay. On the whiteboard, I'm drawing 2 contracts. One is called the proxy. The other is the implementation. The bank's Java app, our connector service, only ever talks to the proxy. The proxy has a permanent, unchanging address. It doesn't contain any business logic. It just has one job: delegate all calls to the current implementation address.
And the implementation contract has the actual code, the functions like record loan state.
Right. If we find a bug, we deploy a new implementation contract, let's call it V2. Then an admin sends a special transaction to the proxy contract saying, update your pointer to the new V2 address.
So the Java app doesn't need to change. The address it calls is the same.
No changes needed in the Java code. It keeps talking to the same proxy address. The proxy just routes the call to the new fixed logic. And the storage, the actual loan data, stays in the context of the proxy, so we don't lose the loan history. This is standard practice, often using the Open Zeppelin UPS or transparent proxy standards.
Okay. That's the safe pair of hands answer I needed. You aren't just throwing code onto the chain and hoping for the best. You're planning for failure.
I've learned that lesson the hard way. I've seen projects lock themselves out of their own contracts because they didn't plan for upgrades.
Okay, let's zoom out. We've covered the tech in depth. I want to talk about Sachin fitting into this team.
The culture fit.
The job spec says, provide input and decisioning, manage and reduce blockers. You've been a lead at DirectLine. You've also been a solo founder at ChainCron. Which one of those people shows up to work here?
That's a fair worry. The founder mindset is move fast, break things. The bank mindset is move carefully, document everything, and then have 3 meetings about it.
Right. If you come here and try to cowboy code a smart contract and deploy it to our private network without going through the change approval board, you're going to get fired. Or worse, you'll trigger a regulatory audit.
True. But here is why the hybrid profile is so powerful. The bank needs velocity. They are competing with fintechs that can ship features in a week. If they just hire safe developers, they will build a safe but ultimately obsolete dinosaur. Sachin brings the habit of shipping.
That evidence.
Look at the hackathons on his resume. SF Tech Week 2025. He's putting himself out there building prototypes in 48 hours. He brings that energy. But, and this is the key, because he survived 5 years at Direct Line dealing with fraud, rigorous testing, JBoss migrations. He knows how to channel that energy through the corporate pipes.
He knows how to write a JRA ticket.
He knows how to write a comprehensive JRA ticket. He knows that done doesn't mean it runs on my laptop. It means it runs in UAT, it has 90% unit test coverage, it has passed the security scan, and the documentation is updated.
And looking at his open source contributions, I see Elasticsearch, LangGraph. He's not a silo. He contributes back. That suggests he can mentor the junior devs who have never seen a line of Solidity before.
Exactly. The reg mentions foster a culture of collaboration. He can be the guy who teaches the pure Java devs what a smart contract is without making them feel stupid. He can demystify the magic internet money tech for them.
Okay. The interview is wrapping up. The whiteboard is full of diagrams, microservices, event buses, proxies, circuit breakers. We shake hands. You leave the room.
I'll walk out, check my phone, probably grab a fresh coffee. The adrenaline dump is real.
Now I'm alone in the room with my notes. Do I hire him?
What's the verdict, manager?
It's a yes.
There's always a but.
It's a yes with a very specific onboarding plan. The risk is flight risk. He's built his own platform from scratch. He's tasted the freedom of being a founder. If we put him on a project where he's just fixing Log4j vulnerabilities for 6 months, he's going to quit.
He'll get bored out of his mind.
Instantly. We have to put him on the GLT control plane project from day one. We have to let him touch the new tech. If we bait and switch him, hire him for crypto, put him on legacy maintenance, we lose him in 3 months.
That's a management challenge, not a candidate flaw.
Agreed. Technically, he is the unicorn we asked for. He bridges the gap. He understands why a concurrent modification exception happens in Java, and he understands why a transaction runs out of gas and Solidity. That intersection is incredibly rare.
It's so rare. Most crypto devs don't know enterprise patterns like a circuit breaker, and most enterprise devs are, frankly, terrified of crypto.
So we hire him. We make the offer.
I think it's a great call, and it brings us to a bigger point for our listeners, I think.
What's that?
The evolution of the back-end developer. 10 years ago, back-end meant I talked to a database.
Right. SQL, Oracle, maybe Mongo if you were adventurous.
Now, look at this simulation. Back-end means connecting AI agents, blockchains, legacy mainframes, and cloud microservices. The definition of back-end is shifting from being database-centric to being ledger-centric and agent-centric.
That is a profound shift. We are moving toward hybrid architectures. The bank of the future isn't just a vault with a SQL database. It's a node in a global network of value. And the developers who can build those bridges, the Sachins of the world, are going to be the most valuable assets in the market.
So if you're a listener sitting there with your Java manual, maybe it's time to download a Web3 wallet and break some things on a testnet.
And if you're a crypto-native dev who lives on Etherscan, maybe go read up on the transactional outbox pattern. You might need it when you get that bank job.
Exactly. Okay, that wraps up our simulation. We hope you enjoyed this deep dive into the architecture interview.
It was a fun grill.
It was. We'll be back next time with another stack of sources and another deep dive.
Until then.
Keep learning.
See you in the repo.